I want to make a quick video about the reader, and a couple of messages came in about students who couldn't find the questions or couldn't deal with the format being sideways. Um, the formats do get crappy sometimes. A lot of these things are old printouts that I've only digitized one way, and it's kind of tough for me to rearrange them because they have sort of low quality. And some kids can do the sideways thing and some can't, because some kids are working on an iPad versus iPhone versus laptop versus computer. So if the formatting sucks, remember that you can do a screen capture and then rotate or lock your screen. You could also use a PDF editor to make them sideways. You could turn them into JPEGs or turn them into Google Docs. I'm sorry about the formatting. I know it's crummy. This was the easiest way to get a single file out to everyone. It has actually been a little bit of a letdown, how difficult it is for people to use digital content differently, different devices, different situations. I also wanted to talk about the goals in the reader. They're normally in the same order in the study guide as they are in the reading packet. So like your book, you go in order until you see the stuff that's in the next question, and then you read that stuff and answer the questions. There was only 5 study goals that had stars in this reader. I'd like to quickly poke in on those. Habitat fragmentation, as I mentioned in the extinction lecture, is when a large piece of habitat is interrupted by human activity of some sort. You can have natural fragmentation, like when an island breaks off from the mainland and becomes separated. That's a fragmented habitat. But usually we use that term to discuss human development, like building a road will divide the habitat into 2 pieces for things that cannot cross that road. Likewise, a city, a factory, a farm. Connectivity of habitat is the opposite. And of course, there are some things which are more mobile than others. So technically for red-tailed hawks, which aren't all that picky, it's pretty tough to fragment their habitat. For salamanders, it's very easy to fragment habitat because they need a certain amount of moisture, for example. So connectivity is connecting pieces of habitat, and fragmentation is development that divides habitat. We have to clarify something about climate change, and I need you to put this very precisely in your notes. The temperature of climate change is rarely a cause for extinction. I think I discussed this in the extinction lecture, but I also want to be very clear. Temperature very rarely could cause an extinction. Even a polar bear loves warmer weather. Technically speaking, the amount of temperature change will not, in and of itself, cause extinctions. However, climate change will cause a lot of extinctions, not because of the temperature, but because people will respond differently. Like my wife and I, we're pretty snuggly when we're around the house because, you know, we're, I don't know, old people, whatever, we like each other. But when we go to the beach, she likes to be in the sun and I like to be in the shade. We both like the beach, but our relationship responds differently when we're at the beach because I like shade and she likes sun. See, we respond differently. Now, remember that there are relationships between species, right? Like a pollinator and a flower. The flower depends on the pollinator depends on the flower, right? So that pollinator is used to feeding on the nectar, and the flower is used to tricking the pollinator with nectar so that that pollinator will carry pollen to another flower, right? Both of these species rely on each other. On a warming planet, neither of those will die because of temperature. Flower doesn't give a crap. Fly doesn't give a crap. Temperature's fine. But if these guys hatch earlier and these guys flower later, I just made that up, I don't know, then they wouldn't line up anymore and they could both go extinct because their relationships break down. Each species responds to climate change differently, and now they may not overlap in their biome anymore. I hope that makes sense. What's happening here is relationships are breaking down. Species will go extinct, because they lose the timing or the place that was critical to a relationship with other species. And there's a lot of those relationships. So that's called ecosystem shear, the idea that the ecosystem falls apart because all the species can respond, but they respond differently. Number 36, mitigation is a trade. You might have heard of carbon trade or carbon offset. It's when you do something beneficial to make up for doing something harmful. So for example, the Santa Barbara airport wanted to extend the runway into a creek. And they said, hey, California, am I allowed to extend the runway into the creek and reroute the creek? And California said, well, you're kind of messing up that creek. What are you going to do for California? And the airport said, well, how about I do a huge habitat restoration on all these other wetlands? The state says, well, okay, so you want to trade doing some harm to this area, impacting the creek by extending the runway. How good is your restoration? And there's all this science involved. And the airport has to prove, well, for every acre that I messed up on the runway, I will restore 5 acres of wetland somewhere else. And ecologically, that should be a good trade. If you look at number 40, that's called a mitigation ratio. It's usually 4-to-1. For sensitive habitats, maybe you need 5-to-1. The idea being that the stuff that you make up is never as good as the original. In number 36, there was this dude that was sending his government employees all over the planet, and they had to fly. And when you fly, you add carbon. So homeboy said, I really need these people to travel internationally. The harm I do is I'm adding CO2 to the atmosphere. So the guy said, hey, how about we trade a mitigation to that? Because we're adding CO2 in terms of flying our government officials. What if we subtract CO2 by funding wind turbines in developing countries? Idea goes, if I can take away a whole bunch of CO2, maybe I'm not a jerk for adding a little CO2. That's mitigation of CO2. It's when you trade. Hey, Mom, I know I wrecked the car, but I'll do the dishes. Maybe that would work. I don't know. Finally, bioremediation, number 39, is when living things solve a problem. The really famous ones are when streams or wetlands fix up water quality. It's kind of magical that you can dump the nastiest water into the top of a wetland and out the bottom comes much cleaner water. There's all these details that we can discuss later. Don't worry, we'll come back to this. But the idea is that big organic compounds are decomposed and nutrients are absorbed. And so you can have like really flooded, grotesque water inputs. Most of that can be resolved by living things in the water. So the water ecosystem works as a filter. It's called bioremediation. One of the big problems with farms is fertilizer runoff. You don't want to have too many nutrients. So one thing that we do is we build these things called bioswales, which are man-made wetlands, or man-made streams, excuse me, that capture the runoff from a farm and will fix up that water quality before the water continues to run off into natural bodies of water. The idea goes that living stuff solves problems. That's called bioremediation, and there are examples that you'll need specifically later. But at this point in the game, I just want you to know that's a thing, usually associated with wetlands. Artificial streams are called bioswales. And that was a short video. Look at that, 5 study goals in 10 minutes. I'm proud of me.